All right, so in this lesson, I'm going to talk about how to solve and graph compound inequalities. Now, there's two types of compound inequalities. There are unions, and there is an intersection. So we have unions and intersections. Now, when I'm talking about a union, I am looking at where what two things are together or combined, right? A union, you think about a marriage being a union, well, that is the two becoming one. And so if we see two equations, equation A, we have equation B, they're a union when we use this word in between, the word or. So A or B means a union. Now, in reference to like the solution of inequality, and the solution for an inequality is always on that number line. It's gonna draw out a simple number line here. All right, we don't need numbers yet. So if I say that A is represented by this, let's see, this solution set, so everything from -1 on back, and B is everything including 2 and going forward. Well, the solution for the union of A or B is this whole thing, everything to the left of -1 but not including -1, and then to the right of 2 but including 2. That's the union. Now the intersection, this is represented by A and B, right? A and B. This, I look at this on a number line. All right. And I have two inequalities, and I want to talk about the intersection. The intersection is what they share together. All right. If I think of the intersection of two roads, all right, here's one road, here's another road. The intersection is everything that they share, they have in common. That's what we refer to as the intersection. So the same on this graph, the intersection here is A and B together. And so we're really not going to be talking a whole lot. I mean, sometimes you might see this, but the intersection of, right, everything from here to the left and here to the right, there is no intersection, right? There's no solution there for that compound inequality. But if I have, let's say, we have, all right, that's a solution set of one inequality. That's from -2 to the right, but not including -2, or everything greater than -2. And then if I have everything from, we'll do 0 to the left, including 0, so x would be less than or equal to 0. Well, then the intersection is everything that they share. And so they share this point and all this stuff in between, right? They share this, but then this inequality here, this solution set of the inequality does not share this point. So we have an open circle there. So the actual solution is just this part right there. That's my solution. My solution then would be x is, well, it's going to be greater than or equal to -2, but I'm sorry, greater than -2, not equal to it, but less than or equal to 0, right? And that would be my solution. Algebraically or symbolically, that's how I'd write that, and then graphically I'd write it like that. Here, this is the graphic solution, or the the graphic solution for that that compound inequality. I could also write that as x is less than -1, or x is greater than or equal to 2. Right, and so that's the algebraic or symbolic solution, and that's the graphic solution. Again, the solutions can be represented two ways. So that's the solutions for these. All right, now we can get into solving them. This video is going to be a little bit longer than I'd like, but so if we have, let's see here, let me get a problem. Let's do 4x minus 4 is less than 8, and 9x plus 5 is greater than 23. All right, so those are my two inequalities. Take a little sip of coffee there. All right, so let's look, what is that solution going to be? Well, for one, we're just going to solve this for the variable just like we would an equation. Adding 4 to both sides. That gives me 4x is less than 12. And I'm going to divide by 4, give me x is less than 3. Okay, so I know that. And when we go on to this one, so I'm going to solve this. I'm going to subtract 5 from both sides, giving me 9x is greater than 18. All right, and then divide by 9 on both sides of the inequality, and we have x is greater than 2. Now notice I didn't have to flip that inequality because I'm not dividing by a negative number. All right, so my solution is this and this. Now graphically, all right, we should be able to express a solution both algebraically and graphically. Well, let me write out this number line. Notice I'm dealing with the numbers 3 and 2. Those are important numbers. So I'm going to put 0 over here. 1, 2, 3, 4. I'll put in -1. All right. This number line has kind of in the middle the numbers I need to deal with. So we have x is less than 3. And so that means anything at 3. And it's less than, so going to the left, and then x is greater than 2, open circle there, and going to the right. And so there is the graphic solution to my to this compound inequality. All right, and I can do, so that was an intersection. I can do a union problem. All right, and let me get a union up. All right, and so here, let's do 3x minus 91 is greater than -87, or 21x. These big numbers shouldn't scare you just because they're big. We're going to deal with them the same way. Is greater than 25. Okay, so this is a union. It's the or, so let's add 91. Add 91 to both sides again. I'm just going to solve each of these for the variable independently, and then I'll take a look at the solution at the end. So this gives me 3x is greater than -87 plus 91. All right, so that is going to be, well, I can think of this as 91 minus 87. I could switch the order of that. Think about 91 heroes, or sorry, 91 heroes fighting 87 villains. After they fight, we have 4 heroes left over. All right. So there we go. Then I divided both sides by 3. That gives me x is greater than 4/3. All right, great. Or, and now over here, plus 17 plus 17. So now I have 21x is greater than, well, that's going to be 30, 42. 42, divide by 21 on both sides, leave me with x is greater than 42 divided by 21 is 2. All right, and so that's the solution. X is greater than 43, or x is greater than 2. Now, I can write this we can write this down here graphically. We can just look at this. What is this graphically? All right. Well, 4/3 is a little bit over 1. So then we got 2. So let's go 0, 1, 2, 3. And so I have x is greater than 4/3. So, all right, if I break these up into thirds, all right, I have 1/3, 2/3, 3/3, 4/3. So x is greater than that, open circle. And I'm going that way. Remember, this is in a union, so everything together. And then x is greater than 2, so an open circle here. And going that way. So what they share together is everything from here, not including 4/3, going to the left. So my solution would be then x, erase that, x, or my solution is everything greater than 4/3, right? Because that already encompasses x is greater than 2. That has both of those solution sets in it. All right, and that is it.